All right, guys, so in this video, we are going to look at the real number system. So the real number system is broken down into two major parts, rational and irrational numbers. We're going to spend the majority of our time with rational numbers because that is going to be where you see the majority of elementary math fall into, but we are going to mention this other side of irrational numbers. So you can see on the screen there just a quick evolution of real numbers. They originated with counting numbers, and so think about having sheep. If I go out and someone asks me how many sheep do I have or how many cow, livestock in general, that would always fall under the counting numbers. 1, 2, 3, 4, 5, up to infinity. However, what if I don't have sheep? So then there was this idea that we need a placeholder for nothing. We need a number to establish that there isn't something. And then as people started trading, there was the, not invention, but there was the establishment of in debt or negative numbers. What if I had 5 sheep and I traded that for something that was worth more value? Then I would be in debt, I would be negative to another individual. And then from that, we had to take into account parts of a whole, fractions, and then there are things that do not fall in those categories, and so we called everything else irrational, meaning not rational. So let's look at more of a diagram to distinguish between the types of numbers. On the outside, you have this idea of rational numbers. So any circle that is inside concentric, meaning within, is going to be a subset, just a fancy word for a smaller part of the larger group. So we've got these rational numbers. Rational numbers can be written as a fraction. So in decimal world, that means the decimals are going to be two types. Terminating decimals, because we learned how to write those as fractions in the last chapter. Terminating decimals would be something like 0.25. If you remember from the earlier part of chapter 7, we said, well, that's 25 hundredths. So we could write that as the fraction 25 over 100. And then, of course, we could reduce. Repeating decimals are also rational numbers, something like 0.1 repeating or 0.12 repeating. Just a recap from last chapter, we said that we could write that over 9. And so 0.1 repeating was 1/9. And remember, if it was more than one digit, in this case 2, we would put it over 9/9. If it was 3 digits repeating, we would put it over 999. And then any of your common fractions. So if it's written as a fraction, 13 over 7, 1 over 2, all of these are going to be most specifically rational numbers. Rational, the first 5 letters being ratio, is because I can write them as a ratio, as a part to whole. Inside, more specifically, we have integers. Integers are our numbers on a number line. So, -4, -3, -2, -1, 0, 1, 2, etc. So positive and negative, quote unquote, whole numbers. No fractions, but they do include negative numbers. So these are the numbers that you find on a number line. The marked numbers on a number line, let's say that. Whole numbers now include 0. And so the great thing about this, that little O in the middle hopefully reminds us that these are the numbers 0, 1, 2, 3, etc. And then counting numbers are called counting numbers because if a little one learns to count, or if you are counting sheep, you typically start at 1, 2, 3, 4, etc. I did make a note down here. Counting numbers, you can also hear them referred to as natural numbers. So counting numbers and natural numbers are the same. And then on the other side, the other type of real number are our irrational numbers. The stem ir meaning not rational. And so these are anything that cannot be written as a fraction, and more specifically, non-terminating, non-repeating decimals. So cannot be written as a fraction. The most famous one, pi, and then you've got square root of 2. Square root of 2 cannot be written as a fraction. It is a non-terminating, non-repeating decimal. So if you were to type in the square root of 2 in your calculator, you get out 1.41213563073095, etc. So that is an irrational number. Another one would be the square root of 3, square root of 71, any non-perfect square. So the square root of 9, while it looks at first glance, the square root of 9 looks like, oh, I'm going to stick it over here because it's a square root. However, the square root of 9 is 3, which then falls over here with my counting numbers. So don't think just because it's a square root that it is going to be an irrational number. A quick check in your calculator. If you have a graphing calculator, you type in the fraction, and then if you do math enter, it will convert a decimal to a fraction. If it keeps giving you a fraction back, if it keeps giving you a decimal back again, then that means it is an irrational number. If you have a scientific calculator, my TI scientific calculators, you're looking for the F2D button. So let me switch over to my calculator and show you what I mean. So if I've got, here's my TI, if I've got a irrational number, something like the square root of 12, when I type that in, I get this decimal, 3.46410, etc. Now that to me looks like a non-terminating, non-repeating decimal, but just to verify, I can select math on that left-hand side, enter. Notice how it gives me back out the same decimal over and over again. That tells me it is an irrational number. So in the next video, we're going to look at classifying irrational numbers.